Okay, here's a final exam review problem. It's a heat transfer problem, pretty easy one. So let's go through it. All right, so first of all, we have the heat transfer equation that I've already written down. So that's given here. And then we know some things from the problem statement. We know we have a 1,750 square foot attic. We know the insulation is R30. And then if we read through there, R30 means that it has a thermal resistance of 30. The thermal resistance is defined as delta X over K, so the delta X is actually built into that number. All right, and then we can look at the units, and this is the important step. Look at the units to determine, what the answer is going to look like in terms of units. Okay, so we have Q, and we're wanting to know what are the units for Q when we get our final answer. We know that area is feet squared. We know temperature difference is delta F. Oh, and by the way, how do I know these things? Well, that's what's given in the problem, and I don't have to do any conversions because I know thermal resistance is in hour feet squared degree F per BTU. Okay, so that was given. All right, so plugging in these units, plugging in for R, on the bottom I would have hour feet squared degree F, and then divide by BTU, so BTU comes up on the top. All right, so remember, what I'm looking for is units here. All right, so I see that the feet squared cancels. All right, I see that degrees F cancel, and my units that are left for Q is BTUs per hour. All right, so I'm feeling pretty good about that. Now it's just a matter of plugging in. We have the 1750, that's in square feet. We have delta F, which is 65. It's given to be 65 minus 30. Okay, so that number is 35. And then we know that the R value is 30. All right, so that lets us calculate Q. So Q is going to be 35 divided by 30 times 1750 in BTUs per hour. All right, so hopefully you get all the steps there. Check the units, look at the dimensions, make sure everything's consistent, and then report your answer in the correct units.